Hello, this is Britt Caswell with a video on the discriminant, which is a portion of the quadratic formula. Just a reminder, the quadratic formula is the formula that we use to find the solutions from the standard form of an equation. Okay, so here's the quadratic formula. And the a, b, and c values that you see in there come from the standard form of the quadratic equation being set equal to 0. Now the discriminant is the portion of the quadratic formula that is written underneath the radical. And what it does is it tells us the number of solutions. Okay, that number of solutions comes from the discriminant. And it tells it to us in different ways. So if you simplify that discriminant value and you get something that's greater than 0, so you get a positive number, okay, like a 7 or a 43 or something. It could even be like a perfect square number, like a 36, and get rid of the radical. Okay, if you do that, you'll have two real solutions. So what that's saying is that you might have a parabola that crosses like this, okay, where it intersects the axis here and here. It could also be a downward facing parabola, okay, but it is certainly crossing that x-axis twice. Now, if you go to solve it and you get 0 underneath that radical, which causes the radical to go away, you're going to have exactly one real solution. So what that's saying is that our parabola is coming down and it's just barely touching the x-axis just in one spot, and then it comes back. Okay, so it's saying there's one spot that it touches. It could also be going this way and touching it in just one teeny tiny spot that way. Now our third case is if we get a negative value underneath that radical. So if our discriminant is less than 0, you're going to have 0 real solutions. So what that means is that our parabola might loop up like this, and it never touches the axis, or it could come down like this. Alrighty, so let's do a couple of examples just to see how we would apply this. Okay, so here's our first example. So first we need to identify our a, b, and c value. So my a here is 2, b is 7, and c is 1. So I'm going to use the formula b squared minus 4ac and plug in those a, b, and c values. Now remember, if you substitute something into an equation, make sure to use parentheses, because those negative values do change things around if you mess it up. Alrighty, so where the b is, I put 7, a is 2, c is 1, and then now we simplify. So 7 squared is 49, minus 4 times 2 times 1 is 8. So my discriminant here is 41. So this tells me that it's positive, okay? And I will have two real solutions. Now I would use this as a mathematician along with this a value. Remember, the a value tells us if our parabola opens up or if it opens down. So because this a value is positive, it opens up. So I know that my parabola will look something like that. I'm not sure exactly where it crosses yet. I'd have to finish solving the quadratic formula. And I don't know where my vertex is perfectly, but I know it's roughly a shape like that. Alright, so our next example. Our a value is 3. Our b value is -6, and our c value is 3. So b squared minus 4ac, I would get negative 6 squared minus 4 times 3 times 3. Negative 6 squared is 36, and 4 times 3 times 3 is 36, leaving us with a discriminant of 0. So this tells us there's exactly one real solution. Now I can find that solution, right? So the quadratic formula, okay, so the square root of our discriminant, sorry, b squared minus 4ac. So I could finish the quadratic formula on this, and it will tell me the solutions. So if I was really curious, okay, so there I've plugged in the 0 for my discriminant, the negative 6 for my b, and then my 3 for my a. Notice I have a negative negative here. So negative negative 6 is just a positive 6. Plus or minus, the square root of 0 is 0. So if I'm adding 0 or subtracting 0, it's not doing anything. So all of this stuff on top is just a 6. Down below, 2 times 3 is 6. So I get x equals 1. So now this parabola, if I were trying to graph it, we know it has one real solution, and that solution is at 1 on the x-axis. So this parabola touches here. And then because a is positive, we know it opens upwards, so it's going to look roughly like that. All right, one last example to solidify this concept. So here I have a is negative 2, b is negative 1, and c is negative 10. So if I plug that into b squared minus 4ac, I get negative 1 squared minus 4 times negative 2 times negative 10. So negative 1 squared is just 1 minus 4 times 2 is 8 times 10 is 80. Checking out those signs, I have 1, 2, 3 negatives. That's why that stays as a minus. So the answer here is negative 79. So because that discriminant's a negative value, there are no real solutions. So if I was trying to look at a graph, first thing, I notice that my a value here is a negative 2. So that means this parabola opens downwards. And since there's no real solutions, it's not going to touch the x-axis. So it'll be something down like that. And that's it. That is our information on the discriminant. Hopefully, it is helping you to see the next part. Until next time.